Madam Hema, madam, over to you, madam.
Okay, sir. I'm giving introduction. I'm K. Haimauti, Assistant Professor at CSE Department, NIRCM, sir. It is my pleasure to welcome you all to the AICT ARTEL sponsored 1 week online faculty development program on deep learning techniques for object detection from 3rd February to 8th February, organized by School of Computer Science, Narasimha Reddy Engineering College, Hyderabad. I extend a warm welcome to our resource person, Dr. Asadi Srinivasulu, sir. Now I'm going to introduce Dr. Asadi Srinivasulu. He received his BTech in Computer Science and Engineering from Sri Venkateswara University, Tirupati, Andhra Pradesh in 2000. He completed his MTech in Intelligent Systems from Indian Institute of Information Technology, IIT, Allahabad, Uttar Pradesh, India in 2004. He is currently pursuing a double PhD in Artificial Intelligence at the Indian Institute of Information Technology, Allahabad, IIT. He earned his PhD in data science from JNTUA, Anantapur, India. Currently, Dr. Asadi is a visiting professor at CRC Care, the University of Newcastle, Australia. Previously, he worked as head of research and open labs in the information technology at Bluecrest University, Monrovia, Liberia, and he has been working as a SME at Deloitte, Delhi from 2020 to 2023. He has 22 years of teaching and industrial experience and served as head of Department of Information Technology at SV College of Engineering, Tirupati from 2007 to 2009. He also holds several professional certifications, including 7 IBM professional certifications such as RAD, RFT, DB2, RTC, TDS, Lotus, Domino, and WID, and 2 Microsoft certifications, 3 edX certifications, 2 TechGig professional certifications, 2 Cybrary micro certifications, 2 Udemy certifications on Python, 2 Solo certifications on C++, 9 NPTEL certifications, and 4 Spoken Tutorial project certifications from IIT Bombay. His area of interest include data science, big data analytics, data mining, artificial intelligence, robotic process automation, cloud computing, pattern recognition, machine learning, and software engineering. He is a professional member of several organizations, including IEEE, Scopus, Web of Science Researcher, CSI, ACM, ISTE, IAENG, IACSIT, ICST, SCIEI, VSRDIJ, NASCOM, ASDF, Meeting Fora, and ICA. He serves on the editorial boards of several journals, including iManager's Journal on Cloud Computing, SCIERA Journal of Computers, International Journal of Advanced Research in Computer Science and Electronics Engineering, Hindavi Journal of Advances in Management Sciences and Information Systems, and International Journal of Research Innovations in Engineering Education. He is also a professional reviewer for several publishers, including Springer Nature, World Journal of Engineering, IEEE, Springer, Elsewhere, Inder Science, Hindavi, CSI, Journal of Advances in Management Sciences and Information Systems, Data Mining and Knowledge Management, IAENG, Biosciences, Biotechnology Research, Asia, and VSRD-CSIT. Throughout his career, he has performed various roles such as HOD, R&D, NBA, POS, NAC, TEQIP 2 and 3C, NPTEL, EDC, TGMC, AICTE, SIP, STP, and IBM COE coordinator. He has guided 3 PhD students and 5 students who are pursuing their PhD, as well as 14 MTechs and 62 BTech students. He published over 196 papers, 24 of which are in SCI and 40 in Scopus and WS, with remaining UGC listed in international journals and conferences. He has attended over 195 workshops, symposiums, and seminars, and has conducted and acted as a resource person for more than 125 international or national conferences, workshops, symposiums, and seminars. He's accomplished author with 8 published textbooks, including data science applications using Python programming, data science, machine learning techniques, navigating the information landscape, exploring NLP and information retrieval synergies, from text to insight, a journey through NLP and information retrieval fusion and methodologies for software testing. He has a book under review titled Machine Learning for Space Exploration and has also contributed to 27 book chapters. Additionally, he has obtained 4 patents. Dr. Asadi sir has received 2 DST SERB seminar grants worth rupees 1 lakh and 9 lakhs, and his publications are listed in digital libraries such as Springer Nature, IEEE Explorer, Elsewhere Explorer, Springer Explorer, SCI Indexed, Scopus, Web of Science, World Journal of Engineering, IGI Global, IJCA, Bookman International Journal, IJIS, IJCSNS, JSCRIJ, PDF Digital Library, IJC, SET, IJRCSC, CSSE, Horizon Publications Helix, CSI, Cognizance Journals. Dr. Asadi sir has received several awards throughout his career, including the Bharat Vidya Ratan National Award from the International Business Council, Delhi in 2018, and the Best IT Teacher of the Year award for the State ITAP 2020 from ITAP and Tutors Pride, Hyderabad. He also received Lifetime Achievement Excellent Award 2022 and Best International Scientific Researcher Award from Research India Foundation in 2022, as well as the Outstanding Teacher Award 2022 for academic year 2022 to 2023 from RIF. Dr. Asadi sir has visited many countries including Malaysia, Thailand, Singapore, Ghana, Kenya, Ethiopia, Dubai, Sri Lanka, Bangladesh, Liberia, and Australia. He has received numerous other awards including Best Mentorship from IBM, TGMC Challenge Contest, and Microsoft in 2011 and 2012, Best Spock of NPTEL SWAYAM, Best SPOC of SDP IIT Bombay in 2019, and the Best Mentor Internship Award from Internshala AICTE Delhi in 2019. Now I invite Dr. Asadi sir.
Yeah.
Uh,
Madam,
sir.
dear all participants, today resource person, thrilled to announce that today resource person is a esteemed expert with a vast experience and a wealth of knowledge in computer science engineering. He is a true visionary in computer science research and education. His work has not only contributed to advancing technology, but he is also inspired many students and researchers. His dedication to the knowledge, innovation, mentorship continues to leave lasting impact on the academic community. A true all-rounder in the field, we are confident that we will get greatly benefit from their insights and expertise. Sir, thanking you, sir, for accepting our invitation, sir. Over to you, sir.
Yeah, thank you, Dilip and Madam, for nice introduction. Yeah, today this is the last session. I guess every one of you got very good knowledge in the field of emerging field, and still it is growing like anything in this deep learning. Today I would like to explain few practical demonstrations in the future directions and innovations. What are the latest concepts are available, like transformers. See, in ChatGPT, we are using transformers. Okay, generative pre-trained transformers, how to write a program, how to develop a GPT kind of applications, and explainable AI, and transfer learning, and we can see generative adversarial models, and variational autoencoder. So many advanced concepts today I would like to demonstrate in front of you. There is no hesitation. Whenever, wherever you are getting doubt, I would like to clarify the doubts. So what is meant by deep learning? Learning from the observational data with a deep manner by increasing n number of hidden and input layers, and we are incorporating fine-tuning parameters, activation functions, dropout function, various filters we are applying in order to solve real-time applications. So, thanks to Narasimha Reddy Engineering College, they have chosen very good topic in this generation. So, Madam and Dilip explained about my background, and these are the research interest right now. I'm doing on groundwater data of Australian groundwater data and soil data analytics, PFAS data analytics, and these are my interest areas. These are the publications you can find in various links like IEEE, RCID, Scopus, Web of Science. In YouTube, there are 350 above videos are available all over the world. I'm giving presentations. Those videos I'm keeping in this repository. If you type my name, you will get 350 videos, and you can write any comment on any video. So I'm a corporate trainer, and right now I'm giving training for US MS and PhD students on data science applications using AI, ML, and DL techniques, and even a generative AI application using ML and DL techniques. And this is the 13 core subjects and 4 case studies I'm giving for this corporate training. And I have given a corporate training for Cyber Shiksha in India level at Bangalore. So cyber security applications using machine and deep learning techniques. This is the syllabus of cyber security, syllabus with real-time projects. And this is the data science training syllabus. If anybody interested, I'm available to explain Saturday and Sunday for corporate training. So before going to our topic, deep learning, future directions and innovations, thanks to Dilip, you have chosen very good topic. This is the last topic and very interesting and very tough topics while executing all the applications. I struggled a lot for implementation of all the 15 applications today. And why I am explaining, before going to deep learning applications, you need to have a huge volume of data. Otherwise, no need of choosing deep learning techniques. If the data is medium and low, then go for machine learning models. If the data is very large and a huge volume of data, you can choose deep learning models like CNN, RNN, LSTM, and various frameworks like TensorFlow, Keras, and VGZNet, ResNet, GoogleNet, InceptionNet, etc. So where we are getting a huge volume of data, within 60 seconds, if you see the statistics, we are getting 6,94,000 videos hours viewed within the 60 seconds. 11,035 fake accounts removed within 60 seconds. 10.4 million viewing minutes in Instagram. So where I am getting this sort of statistics? So that's why we are going to use a cloud computing concept in the background, because cloud computing is an internet-based technology. So the backbone for cloud computing is a data center and virtualization. Data center is nothing but a collection of high integrated servers at one place is called data center. That is a backbone for cloud computing. So virtualization is nothing but the ability to perform multiple tasks in a single system by applying virtualization technology, software like VMware, Hypervisor, Zen, Virtual Iron, etc. Why I am explaining? We are storing huge volume of data in the system, server, and data center. So we are getting a huge volume of data from various domains like banking sector, NASA data, and Sensex data, and traffic data, and weather forecasting data. These are the huge volume of data we are storing in the system, server, and data center. If you click this URL, Worldometers, you are getting a huge volume of data and statistics of each country. Can you see my URL? Now I'm retrieving the data from the worldwide. Can you see my screen? Can anyone acknowledge me? My screen is visible?
Yes, sir. Yes, sir.
Yeah, current world population. Can you see here? See, the number itself, very huge number. Today, births today, and deaths today, population growth today. See, by region, by religion, by population density, population by country, all-time total. See, India is 145 crores right now. China, 141 crores. USA, okay, 34 crores. So that's why we are seeing the statistics of world population, past, present, and future. Why I am explaining? We are getting a huge volume of data from different countries of different domains, so that we are processing, and there is a requirement. We are using deep learning models like CNN, RNN, LSTM, TensorFlow, Keras. These all are statistics. We are getting a huge volume of data. So that's why I'm explaining the statistics of the data. If you click same URL, internetlivestats.com, we are getting internet users in the world. Can you read this number? See, very big number. Total number of websites opened, emails sent today, and Google searches today, blog posts today, tweets sent today. If you click this URL, again, you are going to get the statistics in the worldwide. So same thing I have incorporated in this slide. We are, see, day by day, users are increasing. That means data is increasing. Automatically, data size of the data center size also increases. So how do we measure a huge volume of data? With the help of terabytes, petabytes, exabytes, octabytes, zettabytes, yottabytes, brontobytes, and geobyte. This is the way we are measuring the data. Same thing we are representing in mathematical terminology. Then this is the training of data science syllabus. So no need to discuss all those things. So this is the core syllabus of data science. These are the Python programming syllabus. These are the top 10 libraries of to solve real-time applications of deep learning applications. Python for everything, statistics, and data structures and algorithms, database management and warehousing, artificial intelligence. There are 50 concepts. Usually I'm going to demonstrate with the practicals. Generative AI with 10 topics. Then data mining concepts, natural language processing syllabus, big data technologies, artificial neural networks, machine learning, 3 approaches like supervised learning, unsupervised learning, reinforcement learning. This is our topic today, deep learning, 12th module. So there I am explaining top 10 future directions and innovations of deep learning. Today I am going to demonstrate how to create a neural networks, fundamentals of neural networks, then CNN, LSTM, and transformers, attention mechanisms, generative adversarial networks, variational autoencoders, deep reinforcement learning, explainable AI, federated learning, and privacy preserving AI, optimization techniques for deep learning models, deploying deep learning models in production like machine learning operations and cloud artificial intelligence. These are the 10 future directions and innovations of deep learning techniques. Today I am going to demonstrate with the practical session. These are the projects under my data science and artificial intelligence laboratory. So far with my students, MTech and PhD students, we have completed 153 projects. So before going to our deep learning topic, why sir we are giving that much importance for this deep learning? So the future direction is about, very interesting question. The question is, when is our death date? See, sir, what is this question, sir? How do we are finding the death date? So there is a solution for this one. If you ask birth date, immediately we are saying 15th July, like that. So death date, for solving this question also, there is a there is a model called a life to vector model. It uses various deep learning models like CNN, RNN, LSTM, GPTs for solving this death date, find accurate approximate death date we are finding with the help of life to vector model. So it is also comes under deep learning future direction. And See, in this still R&D is ongoing. We are giving input as biological data, lifestyle factors, environmental influences to predict an individual's potential lifespan. We are using various parameters like the food habits, exercises, height, weight, lifestyle factors, and genes, biological data. Finally, we are finding the approximate lifespan of the person. So by using a deep learning, future direction, in that future direction, we are using life to vector deep learning models. So write a Python program how a potential lifespan prediction can be made based on the various input factors such as biological data, height, weight, lifestyle factors, and generate information. So according to our aim, we are importing required libraries like life2vector and importing matplotlib and numpy, and we are defining function to predict lifespan based on input data and a placeholder for prediction logic and example random lifespan prediction. Then input data we are feeding to the system like life2vector and predict the lifespan and plot the prediction. So now I am going to demonstrate this application. Okay, see here. So this is my screen. Okay, so notepad space, Python can be executed in two ways. One is ideally and one more is a scripting way. Now I am going to demonstrate scripting way lifespan. So my file name is a lifespan. See here, write a Python program to demonstrate how potential lifespan prediction can be made by using life2vector model. So just now I have explained, same thing I have incorporated in this program. Now I am demonstrating based on my data input I have given, my biological data I have given, Python space lifespan. See here. Now I am getting, okay. So this is the lifespan, actual 85 years based on my input data, actual lifespan and predicted lifespan we are getting. See, very interesting question. When is our death date? Approximately we are finding 85 and year soon. Soon we are getting that approximate date also based on your input parameters. Still R&D is ongoing, and we are going to see such type of applications, very interesting applications. Okay. So now, if you see same thing, and we are changing few more parameters like, and we are using another model called same for input data set. We are using biological data, lifestyle habits, and genetic risk scores using random forest regression model. For this random forest, it uses a decision tree concept, and we are importing same NumPy, Pandas, Matplotlib, sklearn. Under that one, we are using a train test split, and sklearn is a Python library for solving the machine learning applications. And we are importing directly random forest regression. And this program also I'm going to demonstrate, and we are checking the lifespan of the feature importance in lifespan. What are the features are very, very important. We will find out here. See here. Same second program, CLS to clear the screen, notepad space, lifespan, same. Write a Python program to predict an individual's potential. Okay. Lifespan based on the various input factors such as biological data, and we are using the model called random forest model here. So we are generating synthetic data, and then we are splitting data into training and testing sets, training the model, making the predictions, evaluating model performance, feature importance, visualization. And now I am demonstrating this application, Python space lifespan. See, now we are getting feature importance of our lifespan. See, this is the feature importance lifespan prediction. Okay, so See here, we are getting mean absolute error 10.9 and various parameters like risk score and consumption, alcohol consumption, smoking history, hours per week, body mass index, age, and feature importance score up to 35. So likewise, we are finding very interesting questions by using deep learning models. This is one sample. And if you have a time or 1 minute time, you can open your mobile and you can type my name, Dr. Asadi Srinivasulu. You will find a number of videos on different technologies on artificial intelligence, generative AI, cyber security, machine and deep learning, various IT field, Internet of Things, blockchain technology I have explained. So today's topic is future directions and innovations in deep learning. These are the top 10 future directions today I am going to demonstrate. The first one is a self-supervised and unsupervised learning and neural architecture search, that is NAS, and automated AI model design and transformer models and explainable AI, federated learning, multimodal deep learning, and sustainable deep learning, green AI, and neuro-symbolic AI, adversarial robustness, and quantum deep learning models, etc. And these are the 16 topics I am going to demonstrate today. So, in this deep learning model, there are top 10 models, fundamentals of neural networks. So, today I am going to explain these 10 future directions. So, what is that? What is this image? Can anyone recognize what it indicates? What is the another way of publicizing about Narasimha Reddy Engineering College? There are pamphlets, there are banners, then there are dashboards, scorecards. This is one more way of publicizing about Narasimha Reddy Engineering College. Like now I am publicizing about deep learning. What is the technical name of this image? Can anyone can answer what type of image, what type of jargon of this image? Can anyone give answer in the chat box? Any answer from the participants? It's okay. The technical name of this image is word cloud. So word cloud is one of the way of publicizing about so-and-so technology. We are incorporating all sort of terms, jargons of deep learning here. Then what are the schools of deep learning? See, DeepMind, that company is developed reinforcement learning approach. OpenAI, recently they have launched ChatGPT and they have took the topic transformers. Facebook developed self-supervised learning. Google company auto machine learning. Apple federated learning. Microsoft machine teaching. Amazon transfer learning. IBM quantum machine learning. Then deep learning industries. See, everybody using deep learning concepts even in agriculture field, healthcare, manufacture, retail industry, financial service, insurance, recycling, etc. And what is the difference between machine and deep learning techniques? See here. So if you apply machine learning for finding whether it is a car or not, by applying machine learning algorithm, we are getting the answer is car or not car. But whereas in deep learning model, it gives additional features like what is the car color, who make that car, and what is the model of the car, what is the cost of the car, all the features we are extracting. That's why feature extraction plus classification by applying various input and hidden layers. We are applying fine-tuning parameters, activation function, dropout, various fine-tuning parameters we are applying, and we are extracting minute level features by using CNN, RNN, LSTM, various frameworks. So that's why the deep learning is a method in artificial intelligence that teaches computers to process data in a way that is inspired by the human brain. So that's why it recognizes the complex patterns for the complex data sets as pictures, images, text, audio, video, and other data to produce accurate insights meaningful data, interested patterns, and predictions. So that's why artificial intelligence is a big umbrella, science and engineering to develop intelligent kind based of applications. Under that artificial intelligence, we are having machine learning, learning from the observational data by applying supervised learning, unsupervised learning, and reinforcement learning, and we are solving real-time applications. So deep learning is the extension of machine learning is a deep learning. Deep learning is nothing but learning from the observational data by increasing n number of input layers and hidden layers and fine-tuning parameters and activation function, dropout, and various frameworks we can integrate in self-supervised learning, unsupervised learning. We are applying in these deep learning models. That's why deep learning is a section of machine learning methods that uses artificial neural networks with more than 3 layers to conduct data analysis automatically. So I would like to give you a small analogy of there is an intelligent robot checking right side there is a fire and left side there is a tap with a bucket of water, and the agent is observing the environment. So then select the option, selecting action using policy. If it immediately we are giving signal to the agent to do the action. So whenever it going to fire side, wrong step without a bucket of water. So we are reducing 50 minus 50 points. So we are solving this problem by reward and penalty process. We are achieving the application goal finally in this reinforcement learning. So if it does good thing, we are giving reward. If it does bad thing, we are giving the punishment. So we are updating the policy, that is called a learning step, and iterate until an optimal policy is found. This is best example for reinforcement learning, especially for gaming applications we are using in deep learning applications. Then these factors everybody explained. My renowned previous speakers might have explained the difference between deep learning and machine learning. No need to explain. And here we are using a GPU in deep learning. Here we are using a central processing unit. So these are the various deep learning use cases, like in face unlock in smartphones we are using deep learning, and selfie filters we are using deep learning, networking concepts we are using deep learning, cab booking, Hey Siri and Google personal assistant applications we are developing, personalized marketing, Gmail spam filter, and Play Store recommendation, online food delivery portals. There are numerous we are using in computer vision, like audio, video, text, graphics, animation, natural language processing for conversion of one language to another language, autonomous vehicles, healthcare diagnosis, and climate modeling, drug discovery, fraud detection, recommender system, speech recognition, robotics, etc. So this is the in deep learning process we are using n number of input layers. Okay, so you may ask how many input layers, how many hidden layers? There is any formula? No. Depends on your system, server, and data center. It is a trial and error basis method. You need to choose your own style of number of inputs, hidden layers, and fine tuning parameters, dropout function, and activation functions. Then finally we are getting the output. So in deep learning process, it uses a data collection method, pre-processing for eliminating the noisy, redundant, dirty data, for model selection, training with large data sets using neural networks, optimization, evaluation, deployment for real-world application. We are adjusting the parameters, network architecture, etc. So lots of labeled data, unlabeled data, training set 80%, 20% for testing, validation, and like that. This is a deep learning process. We are using image as a small example for how we are using input layers, like we are identifying light, dark pixel values. Then we are increasing the hidden layers, like identifying the edges of that image, identifying combination of edges, then identify features, and finally we are getting combinations of features. Finally, we are identifying is a George. This is the way of a number of increasing hidden and input layers and fine tuning parameters. So no need of explaining all this theory part. Directly I am going to demonstrate the practical part. So these are the three major models we are using. Deep neural networks, that is DNN, and convolutional neural networks, like it is for image processing purpose we are using. For sequence of events, language models, time series data, audio, video, text, graphics, we are using recurrent neural network model. And there are top 10 learning algorithms like CNN, RNN, LSTM, GAN, generative adversarial networks, transformers, autoencoders, deep belief networks, and restricted Boltzmann missions, RBM, multi-layer perceptron, reinforcement learning based deep Q network, that is reinforcement learning algorithm we are using in a game application development. So these are the deep learning models we are dividing into supervised and unsupervised. Supervised learning means there is a label, there is a target class. Based on that target class, we are classifying the data. Especially we are applying classification techniques like CNN and classic neural networks, recurrent neural networks. Unsupervised learning, there is no label, there is no target class, but I would like to classify the data based on the similarity measure. How do we can calculate similarity measure? By using Euclidean distance, Manhattan distance, Minkowski distance, etc. There are 2 points like x1, x2, y1, y2. We are calculating the Euclidean distance, square root of x1 minus x2 whole square plus y1 minus y2 whole square. We are applying self-organizing maps, Boltzmann machines, autoencoders. We are having top 10 deep learning models like AlexNet, VGZNet, ResNet. Okay, VGZ16, I have applied AlexNet, ResNet, InceptionNet, EfficientNet, YOLO. That means you only look one. BET, GPT, Generative Pre-trained Transformer, Transformers Unit. These are the various frameworks we are integrating with the standard models like CNN, RNN, LSTM, DNN for prediction and time series purpose. We are using deep neural networks, CNN for image classification, computer recognition and vision, and RNN, LSTM for audio, video, text, graphics, animation kinds of classification. These are the top 10 learning models we are integrating with the existing models. These are the deep learning methods, and these are the deep learning code libraries. Nowadays, every day I'm using TensorFlow, PyTorch, Apache, MaxNet, etc. These are the top 10 libraries I'm using. Now I'm going to demonstrate how to use a TensorFlow, PyTorch, Keras. See, TensorFlow, it is a deep learning framework. It is developed by Google company. PyTorch, it is a popular deep learning framework. It is developed by Facebook AI. Keras for using for deep learning library. It is API running on top of TensorFlow. Theano deep learning library for fast numerical computation purpose. MaxNet scalable deep learning framework by Apache. Then Cafe, it is a deep learning framework optimized for speed and modularity. Fast AI, it is simplified deep learning library built on top of PyTorch. Okay, PyTorch is developed by Facebook AI. Chainer, flexible deep learning library supporting for dynamic computation graphs. Deep Learning 4J, it is Java-based deep learning library with Python APIs. JAX is a one more library for deep learning and numerical computing library for optimized for TPU and GPU. So these are the Python libraries, very popular. Why Python is so popular? Because it is having rich number of libraries irrespective of the domains. So these are the top 10 applications of deep learning like computer vision, natural language processing, autonomous vehicles, medical diagnosis, fraud detection, recommender systems, speech recognition, robotics, sentiment analysis, drug discovery, chatbots, self-driving cars, medical care, colorizing the images, photo descriptions, advertisement, etc. So these are the latest applications, again theory part. So these are the top 10 fascinating applications of deep learning, especially in self-driving cars. Already Tesla and Google, they have started and successfully it is running in USA and Australia and UK, Canada. So detection of growth delays in children, automatic handwriting generation, demographic prediction, sound addition for silent films, pixel restoration, and colorization of black and white images, news aggregation, deep dreaming, automatic mission translation. These are the very interesting applications. Same way 20 deep learning applications, and these are the most useful deep learning tools. Nowadays, you need to know it. What are the top 10 tools available in 2025? You need to use it for different applications like TensorFlow, PyTorch, Keras, Hugging Face Transformer, JAX, Onyx, Open Neural Network Exchange, Apache MaxNet, Fast AI, Light Gradient Boost Machine Learning Algorithm, Deep Speed, etc. And these are the top 10 open source deep learning tools. For anomaly, fraud detection, transaction, we are using LSTM, CNN, and RSFMRI, Google Assistant, Marine, etc. And these are the future directions and innovations in deep learning. Top 10. What are the top 10 future directions? Now I am going to demonstrate with the practical session. Now, first topic is a self-supervised and unsupervised learning. What is meant by unsupervised learning? There is no target class, there is no label, but I would like to classify the data based on the similarity measure. How do we can calculate similarity measure? By using Euclidean distance, Manhattan distance, Minkowski distance. Especially we are applying clustering algorithm. Clustering means group of objects, that objects having similar behavior, like k-means clustering, and a few more dimension reduction algorithm like principal component analysis we are using. Self-supervised learning, it extracts useful representation from unlabeled data by predicting parts of data from other parts. That is called self-supervised learning. Now my program, write a Python program to perform unsupervised learning using k-means clustering on a synthetic data set and visualize the clustered data using principal component analysis. I am importing required libraries like NumPy, Pandas, Matplotlib, so sklearn, and we are creating synthetic data set. Now I am demonstrating this application here. Can you see my screen? See here. So first application of future direction, notepad space nr.py. So first application, see here, write a Python program to perform unsupervised learning using k-means clustering on a synthetic data and visualize the clustered data using principal component analysis. We are importing required libraries, creating a synthetic data set and data points up to 200, creating a data frame with the various features of dimensions and applying k-means clustering, that is unsupervised learning. And step 4, applying principal component analysis for, principal component analysis for visualization. Then plotting the results. On X label, we are using PCA component. In Y label, we are using a PCA component too. On the top of the output, we are displaying clustering visualization using PCA. And finally, we are demonstrating. See here. Now I am demonstrating. See, it is coming. See, now my screen, it is opened 3. So now CLS to clear the screen, notepad space nr.py, that program we have opened. Now I am executing Python space nr.py. Now see, now it is principal component analysis and clustering algorithm. Now see my graph. See here. Now see here. There are 3 clusters like cluster 0, the blue color, cluster 1 for the blue color, orange color, cluster 2 is a green color. So likewise, we are demonstrating a very interesting application. Now you can see the next one is this supervised learning. Everybody knows based on the label and the target class, we are classifying the data. Unsupervised learning, there is no label, there is no target class, but we would like to classify the data based on the similarity measure. Then semi-supervised learning, it uses supervised, unsupervised 50% and unsupervised 50%. And for unlabeled data, we are classifying the data. Then reinforcement learning, based on the punishment and reward, we are solving the problem. So this is a self-supervised learning. It is a machine learning process where the model trains itself to learn one part of the input from another part of the input. It is also known as predictive or pretext learning. That's why self-supervised learning it is called. So this is the output just now we have seen. Next, second future direction of deep learning, neural architecture search, that is called NAS, and automated AI model design. So what is mean by neural architecture search and what is mean by automated AI model? See, this NAS automates the design of deep learning architecture, which includes n number of input and hidden layer and fine-tuning parameters to find optimal structures by using NAS. Why we are using automated AI model design? It reduces human effort and improves the model performance. For this NAS, I am writing program, write a Python program to automate a deep learning model using neural architecture search with Keras tuner, optimizing hyperparameters such as the number of layers, neurons, and learning rate to improve model performance for regression tasks. So step one, what we are doing, install Keras tuner if not installed. Then we are applying import required libraries. Now see, I am demonstrating. Now, see, I'm clearing the screen, notepad space, NR1, that is the next program. See here, what is the aim of the program? See here. So the aim of the program, write a Python program to automate deep learning model design using neural architecture NAS with the Keras tuner optimizer. See, in step one, import required libraries. So many libraries I'm importing, creating a synthetic data, then splitting data into train and test data, normalizing the data if any, noisy data, inconsistent data, dirty data, we are applying pre-processing techniques like box plot technique, binning, etc. and define the model building function for neural architecture search. Then we are applying performing neural architecture search using Keras tuner. Then running the tuning process, fine tuning parameters we are applying like epochs, xtrain, ytrain, validation data, like train the best model, visualization, the model performance, etc. Now see, I am executing so this program, see, in my system, it is not supporting. That's why I'm using Google Collaboratory so that my program is executing here. See, new notebook, I'm opening Google Collaborator because of a very big data set I'm taking. So if I run in my system, it takes time. That's why I'm using, this is the program. See, this is the program, Control A, Control C. Now I'm using Google Collaborator. You can run here. See now, I'm running this program. Write a Python program to automate a deep learning model. See, I'm running this program. I'm getting the output here. Can you see my screen? Can anyone acknowledge me?
Yes, sir, we can see your screen.
Yeah. So step one, we are using Keras. And step one, importing required libraries, creating synthetic data. And now my program is running here. See here. So it is downloading. It is performing number of steps. Okay. It is running and visualizing the model performance, running the tuning, fine tuning parameters, performing neural architecture search using Keras. So now my program successfully is running. See now. Now running trial one. Now it is generating required output. So the best value 20 epochs it is running now. See here it is running the program. So here see you can find a timestamp, loss, accuracy, validation, time complexity. So now it is running here. See. So best optimization, it is running itself. So self-learning, it is learning and finally it can displace every time it runs, it chooses the best self-supervised learning model. Now, finally, it can display the output. So it takes time. So that's why, see now, every time again, it starts with the again. See now a 50th step. So now it is running. So finally, the self-supervised learning and unsupervised learning. See, finally I got the result. Model loss during training, and the y-axis I got loss mean squared error, and epochs, number of 50 epochs we have run, and successfully we run the program. We got execution of a number of accuracy loss, value loss, time complexity, and confusion matrix, F1 score, and AUC, ROC. So these are the validation metrics we are getting. So now I'm moving to next concept, next future direction. See here. So NAS uses, these are the input parameters like individual requirements, maximum memory usage, maximum false alarm rate, minimum detection rate, automated neural architecture search. It uses itself, self-learning, and finally we will get optimal design. So this is the output we got it. Next future direction, transformer models. See, in ChatGPT, generative pre-trained transformer uses a transformers concept. Model is nothing but simplified version of the reality, and we are using attention mechanism. These transformers are a process of sequential data using self-attention mechanisms, making them powerful for natural language processing. To solve various natural language applications like one language to another language, we are conversion and vision tasks, and they enable models to capture long-range dependencies efficiently. For these transformer models, I'm writing a program like write a Python program to train a transformer-based natural language processing, that is DistBERT, for text classification, and visualize the self-attention mechanism to understand how the model focuses on different words in a sentence. For required libraries I'm using, and then I'm creating a synthetic data. Now see, I'm going to demonstrate. So CLS to clear the screen, notepad space, NR2, third program. So write a Python program to perform a transformer based NLP model for text classification and visualize. In step 1, install required libraries. Then creating a synthetic NLP data set we are creating. Then step 3, tokenization using DistBERT tokenizer we are applying. Then load pre-trained transformer model, that is a DistBERT. Then define training arguments and trainer. Then we are using train the model, extract attention scores for visualization, and visualizing attention weights. And finally, I'm going to demonstrate this program in Google Colab because it takes time. Okay, so I'm closing this previous program. Now again I'm running with the third program. See here, write a Python program to train transformers on a natural language processing. Now I'm running the program. See here, so there are 7 steps we are using. Installing required libraries. Now my program is running. Okay, so in the first step, what we are doing, we are importing number of libraries, creating a synthetic data set, tokenization using that. See, it is running. Then load a pre-trained transformer model and train model, extract attention scores for visualization, visualizing attention weights. Now my program is running. See, actually we got the output. See, so maybe some so see, this is the concept we have demonstrating. transformer models and attention mechanism. It uses a transformer layer with the re-attention mechanism, transformer layer with the self-attention mechanism. Here it uses patch embedding and patch embedding here. Two transformer models we are using. And this is the output we are generating. This is the output we need to get it. Let me check once again. This is the output we got it actually. For attention weight, a heat map of input sentence, token position. On x-axis, we are getting CLS, powerful deep learning models. Then y-axis, we are tokenization like models, learning, deep, powerful. See, so this is called a heat map. It can it varies the model parameters with values. Easily we can find the what is happening of this transformer model. Next, fourth model, explainable AI for deep learning transparency. So explainable AI is one more latest future direction of deep learning. So in this explainable AI, it enhances the transparency in deep learning models by providing human understandable explanation for their decision. It helps build trust and accountability by revealing model reasoning, reducing bias and improving interpretability in critical applications like healthcare and finance. So in this program, write a Python program to train a convolutional neural network on the MNIST dataset and use SHAP, shapely additive explanations, to visualize and interpret the model's prediction, enhancing transparency and explainability in deep learning. So this is one more future direction. One second. So this is the architecture uses explainable AI for deep learning. It enhances the transparency of deep learning models by providing a human interpretable explanation for their decisions, for improving trust and accountability in critical applications like, see, why did you do that? Why not something else? When do you succeed? When do you fail? When can I trust you? How do I correct an error? See now, that is a task. After applying learned function, we are applying deep neural network model like explainable AI. And it uses the task training data, testing data, new deep learning process we are applying, explainable model, that is XAI, explainable interface. Finally, we are getting the output like, I understand why. I understand why not. I know when you succeed. I know when you fail. I know when to trust you. I know when you erred. So this is the example for explainable AI in deep learning transparency. So this is the output we are getting. One second, I am going to demonstrate this application. So notepad space. This is NR4, NR3. Let me check. Yeah, this is so few programs are still not working properly in Google Colab. Okay, let me check once again. So write a Python program to train convolutional neural network. So this program, see here. So step 1, install required libraries. Then load and pre-process data set like MNIST handwritten digits. And then reshape for CNN input and define CNN model. And then train the model, explainability using sharp model, visualize the sharp explanation for one prediction. See, now my program is running here. See here, it takes 3 steps to complete this program by using convolutional neural network on the MNIST dataset. It is available in pre-repositories like Kaggle, GitHub, and UCI repository you can find. Now see, now step 2 is running now here. Epoch 1 is completed. Epoch 2 is running. Let's see. Meanwhile, because of time, I'm moving. So this is the output we are getting, handwritten recognition. Then federated learning and privacy. Next, future direction. Federated learning. It is also an extension and future direction of deep learning. It is a federated learning. We are running our model on different platforms in their data center or in their environment. We are executing our models. I mean, our application. So it enables AI models to train on a decentralized data across. Suppose I am in Australia, you are in Delhi. So I am using your environment and central computing power to run my application in your computing power. So decentralized data across multiple devices while preserving user privacy. It enhances the data security by ensuring the sensitive information remains localized, making it ideal for application, especially in healthcare application, finance, and personalized AI systems. Then efficient green AI for sustainable deep learning. So it is also being optimized to reduce computational cost and energy consumption, making them more sustainable. So we are using techniques like model pruning. Pruning is nothing but eliminating noisy, redundant, and various parameters by increasing one second. So next future direction. So next future direction, efficient green AI for sustainable deep learning. And next model is, so this is federated learning, privacy preserving AI model, and multimodal deep learning. This is one more future direction. Here we are using multimodal deep learning combines different data sources. Different data sources like we are using images, speech, and text to enhance various models. Yes. So in this multimodal, we are using speech, text to enhance understanding and decision making. This function enables models to perform complex tasks such as audio, video, text, graphics, speech recognition, emotion, and gesture, facial expressions more accurately. So next model is, next future direction is neuro-symbolic AI, that is combining deep learning with the symbolic reasoning. So here AI merges with the pattern recognition power of deep learning with logical reasoning from symbolic AI to improve explainability and decision making. This hybrid approach is useful in fields like healthcare, robotics, automated reasoning. And this is the multimodal deep learning. See here, we are using unimodal 1, 2, 3, and we are combined encoding. Then we are fusion model module, then classification network, and finally prediction. Multimodal deep learning combines audio, video, text, graphics, processing to create more comprehensive and context-aware of AI models for different applications. Then the ninth future direction is adversarial robustness and security in deep learning. We are using a GAN and variational autoencoders for enhancing AI security by making deep learning models resist to manipulated inputs and adversarial tasks, especially facial expressions and motion recognition application. We are using adversarial training, detection algorithms, and robust architecture help mitigate vulnerabilities in AI systems. And the last future direction model is quantum deep learning and AI-powered edge computing. So here we are leveraging means integrating quantum computing to accelerate AI model training and improve complex problem solving. AI-powered edge computing enables real-time processing on decentralized device, reducing latency and enhancing privacy for application like autonomous vehicles, smart IoT systems we are using. So this is adversarial robustness in deep learning. So this is the output. Let me check that previous program, whether it is executed or not. We will check in Google Collaboratory. So still it is running. Let me check one more program, CLS, to clear the notepad space. NR6. This is the. So write a Python program to demonstrate this program we have completed already. 1 second. This is the, yeah, NR6. It is executed. Let me try once again. So this is the program. So let me try and execute in Google Collaboratory. So you can run here. So this is the program. Write a Python program to demonstrate adversarial robust in deep learning by training CNN on the MNST dataset. Now I am running this program. First step, required libraries we are importing, load and pre-process the dataset, defining CNN model, train the model, and generate adversarial network, that is example using FGSM attack, then evaluate model on adversarial example. Then you can see the calculate accuracy and adversarial examples, visualizing the adversarial attack success rate. Now this program is running. Meanwhile, see, it is running right now. We'll move to next concept. So this is the output. I got it finally for that. See, output of adversarial robustness and security in deep learning. In x-axis, we got original data, adversarial data, and y-axis accuracy, impact of adversarial attack on model accuracy. Then we are moving to deep learning evolution. So in this deep learning evolution, we started with the neural networks. ANN is base for CNN, RNN, LSTM, and transformers, enabling breakthroughs in AI application. So what is the current state of deep learning in industries? So especially in a healthcare industry, finance, autonomous systems, and natural language processing. So driving automation and efficiency, we are using these models. Importance of future innovations, especially in we are using explainable AI, neuromorphic computing, and federated learning will enhance AI scalability, security, and ethical consideration. This is one more program. Write a Python program to visualize the evolution and the future advancements of deep learning techniques using a line graph highlighting their impact and progression over time. So let me execute this program. Let me check. CLS, clear the screen, notepad space. Narasimha1. Okay. So this is the program. Let me execute. Okay. So let me execute this program. So see now. So this is the program, deep learning technique using a graph, line graph. So in x-axis, we are taking various models like traditional neural networks, CNN, RNN, transformers, explainable AI, federated learning, neuromorphic computing, etc. In y-axis, impact and advancements levels, evolution and future directions of deep learning. Okay, so now we are moving to next concept. So this is the output, we got it. And self-supervised learning and a few short learning. In this one, we are using labeled data by leveraging patterns in unlabeled data sets, improving efficiency and adaptability. And here we are using models like GPT, generative pre-trained transformers, vision transformers, and BET, especially in NLP applications. Federated learning and privacy preserving. So it enhances the privacy and security, especially in a decentralized environments. And the neuro-symbolic AI, like combining symbolic reasoning with neural networks, and it improves the reasoning, interpretability, and generalization AI systems. And this application already we have executed. Neural architecture such as NAS and automated machine learning. And this is a few shot prompting algorithm, how it is working. This is the program. So let me execute this program. To clear the screen, notepad space. See, it's check the spelling of Narasmatu. Okay. So this is the second program again in the future direction. Write a Python program to visualize the impact and efficiency of key deep learning innovations using horizontal bar. So same this program I'm demonstrating in Google Colab. See now. So how much time is there? So this is the bar chart.
Sir, 20 minutes is there, sir.
Oh, okay. Slowly I will explain. So in this program, see in x-axis we got efficiency and impact. And in y-axis we have a self-supervised learning, transformer-based architecture, federated learning, neuro-symbolic AI, neural architecture search, and etc. Then we are moving to next program concept like see. So this is the program we have executed. Next, explainable AI and AI interpretability. These are the latest concepts in deep learning, future directions. So this explainable AI enhances transparency in AI models by making their decision making. Especially, we are solving the understandable to human format by applying neuromorphic computing and spiking neural networks we are using, especially in these computing models mimic like human brain's neural activity, enabling more efficient low power AI computation. We are using a quantum deep learning, AI powered by quantum computing. It accelerates deep learning tasks by leveraging, means integrating quantum mechanics to perform complex calculations exponentially faster than the classical systems. We are using multimodal learning model. We have already executed one application and Edge AI on one device learning for real-time processing. So let me execute this program also. So CLS, notepad space. So write a Python program to visualize the impact of emerging research trends in AI using a horizontal bar chart, especially highlighting their contribution to AI advancements. Like what are the advancements we are taking. I am executing in Google Collaboratory. See here. So this program I am demonstrating. See, so this is the third program. We are defining the required libraries, defining the data set, then we are performing. So impact on AI advancements like explainable AI, neuromorphic computing, quantum deep learning in y-axis we are taking. Then next we are moving to next concept. So what are the top 10 applications of deep learning? So computer vision. So it uses audio, video, text graphics, images recognition, object detection, and facial recognition we are using. Okay. So then natural language processing application like chatbots, language translation, and sentiment analysis, we are using this deep learning. Autonomous vehicles, we are using self-driving cars and advanced driver assistance systems. In a healthcare and a medical diagnosis, we are using disease detection, medical image analysis, and drug discovery, etc. Speech recognition, we are using deep learning techniques like virtual assistants like Siri, Alexa, Google Assistant, etc. Then these are the deep learning applications like virtual assistants we are developing, autonomous vehicles, face recognition, chatbots, sound addition of silent films, colorization of black and white applications. So these are the top 10 applications, especially computer vision, natural language processing, autonomous vehicles, medical diagnosis, fraud detection, recommender system, speech recognition, robotics, sentiment analysis, and drug discovery. So in fraud detection, cyber security, we are identifying fraudulent activities, transactions, and preventing cyber attacks. We are using deep learning techniques. Recommendation system, we are using personalized content recommendation on Netflix, YouTube, and e-commerce like Amazon and Flipkart applications we are developing. Finance and stock market prediction, we are using AI-driven trading and risk assessment models. Robotics and industrial automation, we are using smart robots in manufacturing, logistics, and warehouses. Agriculture and precision farming, crop monitoring, yield prediction, and pest protection using. Then these are the examples of applications of deep learning. We have used in healthcare, self-driving cars, fraud detection, detection of growth delays in children, deep dreaming, language translations, visual recognition, automatic handwriting generation, etc. So these are the top 10 future directions. Just now we have seen innovations in deep learning. So those are self-supervised and unsupervised learning. That means we are reducing reliance on labeled data by enabling models to learn a representation from raw data. Then neural architecture search, that is NAS, and automated AI model design using AI to optimize deep learning architectures for improved performance. Then we are applying NAS and automated AI model design. Then using AI to optimize deep learning architecture for improved performance and efficiency. Transformer models and attention mechanism like NLP AI applications. Then explainable AI, it is for deep learning transparency we are using. Enhancing interpretability and trust in AI models through explainable techniques. Federated learning and privacy preserving AI, training AI models across decentralized devices. We are executing our code in their environment in the case of federated learning while ensuring data privacy and security. Efficient and green AI for sustainable deep learning, reducing AI's carbon footprint using model compression, energy efficient algorithms, and sustainable computing. So seventh, multimodal and deep learning. We are integrating vision, language, audio, video, text, graphics, etc. in combining multiple data modalities for a more comprehensive and human-like AI understanding. Neuro-symbolic AI, combining deep learning with symbolic reasoning. We are merging neural networks like CNN, RNN, LSTM with the logical reasoning for better decision making and interpretability. And the ninth future direction is adversarial robustness and security in deep learning. So we are strengthening AI against adversarial attacks and vulnerabilities to ensure model reliability, quantum deep learning, and AI-powered edge computing. These are the future directions. These are the top 10 future directions and innovations in deep learning concept. So any doubts if you are having, please ask me. These are my past activities and future activities also I have mentioned. So far 175 webinars, seminars I have conducted on different colleges, different universities. So this is a future coming generative AI application using machine and deep learning techniques at University of Newcastle. If anybody is interested, we are providing certificate from University of Newcastle through CRC Care, and we are providing certificate and material and programs for this one day program. It is an international program, and this is your college, Narasimha Reddy Engineering College. This is Atal FDP. So many programs I have conducted. Okay. And any doubts, if you are having any doubts, please ask me. I'm going to clarify. And only 7 members so far subscribed my channel. What about remaining, my dear friends? Just go to YouTube and type my name, Dr. Asadi, Srinivasulu. You will get my channel, and you can subscribe and write one comment. And meanwhile, Dilip sir, we can take queries from the participants.
Yes, sir. Yes, sir. Dear participants, madam, over to K. Viran Lakshmi, madam.
Yes, sir. Good evening, sir. Good evening, artists. Yes, sir. Dear participants, if you have any queries, you can ask, sir.
How many participants are there, madam, right now?
Sir, it is 151.
Oh, very good. Very good number.
Yes, sir.
Sir, in
Dilip
chat
sir
box,
told one.
yeah, thank you, sir. In chat box, a few questions is there.
Yeah, please, can you read and...
Madam K. Viran Lakshmi, madam,
madam,
over
can
to
you
you,
read?
madam.
Sir, I am not able to see the questions, sir, because I had
Sir,
just joined.
Can you use Python M notebook command to run it, sir?
Yes. Yeah, we can use a command prompt also, and there are 2 ways of executing a Python program. Yes, you can run in a command prompt itself, or you can choose any notebook or any framework you can choose, like PyCharm, Jupyter. There also you can run that program. What is the exact doubt?
Rahul Guha.
Please unmute yourself and ask a query. Introduce yourself and ask any queries.
Rahul, sir, please respond in your chat box. You are posted.
Yes, sir.
Yeah, please, ready to answer the Asadi Srinivasulu, sir. Please ask the question. Introduce yourself and ask the question.
Yeah, sir, I am working as a state professor in JCRC University, and I just want to ask, is there any option? So if my compiler is old, then I can use this command Python -m space
There is.
notebook.
Yeah. So in Python, one drawback is there, like a deprecation problem. In old versions cannot support for for new versions, and new programs cannot support in the old software. So that's why better you can use this Google Collaboratory. You will not get any sort of problem. Rahul?
Yes, sir.
Better you can use a no deprecation problem in your system. You can use Google Colab. Do you have Gmail account?
Yes, sir. Yes, sir. I have
Yeah,
Gmail
then
account.
automatically you can use Google Collaboratory. So Google is providing for us high computing configuration environment where you can run very huge volume of data, very large sets also you can upload, and you can run the program.
But for
Okay.
individual programming, when you want to run our large data set in our local host, so will it be suitable that we are using Colab?
Yeah. There also, just now I have demonstrated, you can create your own scripting file. So then you can open a notepad file, you can write your own program on data set. Then you can run on your local system also. It will support for small data set. It is not a problem, Rahul. You can run.
Because when we are using Kaggle for the large data set,
Kaggle is a repository where you can download a number of data sets.
Yeah, it might be delay somewhere. So we have watched that localhost Jupyter is better than
Correct. You can use it Jupyter. If anybody is interested, collaborate with any research articles or proposal writing, you can take my help, and collaboratively we can work together. Take my
Yes, sir.
number.
We are actually also working with some government projects, so we are interested. I will be connected with
Sure.
you.
You can take my number and you can contact me for any help for research collaboration. We will do some programs. Any other queries?
The chat box,
Participant?
one more question is there. Can
Yeah, please.
transfer learning and XAA deep learning classify the brain tumor?
Yes, very good question. So transfer learning and explainable AI, these are the two advanced concepts of deep learning. So whenever you are giving a brain tumor data set as an input to the system, you need to pre-process the data, then you can combine with the CNN with the transfer learning, RNN with the transfer learning, and explainable AI, so that you will get more accuracy, and you will get very good classification of that brain tumor image, whether that image having a brain tumor or not, what are the causes of the brain tumor. All that one minute level features also we are extracting with help of transfer learning and explainable AI. With the integration of numerous frameworks like InceptionNet, GoogleNet, ResNet, if you combine, so it can extract more features from that brain tumor image. Very good question. Any other queries from the participants? Please subscribe my channel. Nobody, see, so far 11 members only subscribed. There are 150 members. Take 1 minute time. Go to YouTube, type my name, Dr. Asadi Srinivasulu, and subscribe my channel. Write one comment on that any video. Any other queries from participants?
Excuse me, sir. Could you share, please, your LinkedIn profile so that we can connect you personally?
Yeah, you type Asadi. Yeah, just Asadi Srinivasulu. You type. You will get it. I'll connect with you in LinkedIn also. You type Dr. Asadi Srinivasulu, Newcastle, University of Newcastle. You can type.
Sir,
You
one
will
more
get it.
query is there.
Yeah, please.
How to predict the diabetic? Can you please explain, sir? How to
Yeah,
predict?
very good question. Whether the diabetic data set is text data or what kind of data. If it is text data, go with the CNN model. If it is image or audio, video, any kind of you are taking, then go for a RNN model. Yes, we can classify the diabetic data based on various symptoms of the diabetic patient. We are supplying the huge volume of data as a text. Then you can choose fine-tuning parameters, trial and error basis method. You can choose a CNN model. It is suitable method for classifying the diabetic patient data. If it is a text data, go with CNN. If it is image, for image also go for CNN. For audio, video, any kind, just go for RNN with the or LSTM models. Very good question. Any other queries from the participants? At least you can give feedback on this presentation, at least. My dear participants, you can
So we
give
got
feedback
one more.
on. Yeah.
We got one more query, sir.
Please
In
read out.
detection, what is zero shot detection?
Yes. So zero shot detection, I have explained already. See, we are using whenever our data is reasoning with multiple sort of questions or multiple text data you are giving. See, I have explained here in this model one shot. See, one diagram also I have pasted here. Okay. So by using, see, this is a one shot or few shot prompting model. It uses, so here we are using so many examples like text data we are giving, and example 1, example 2, more example, and so your input, so many things we are giving as a few short prompt, then example, then finally we are predicting the model. So in this model, what we are using, so it uses AI ML. See, in this model, we are using generative pre-trained transformers. and it labeled data, unlabeled data, by leveraging patterns in unlabeled data set, by improving the efficiency and adaptability, by with a combination of BERT and GPT and various algorithms where we are incorporating in this few shot prompting algorithm. Timely, you are choosing the best models to run this application. Very good question. Is there any other queries?
Yes, sir.
Yes, sir.
One
One
more
more.
query.
Yeah, please.
Sir, in few short prompting, we have faced some problem of overfitting. So how to overcome that?
Yeah, very good question. In overfitting, what type of fine tuning parameters you are using? You need to check the data size of the data set and the number of epochs, number of so by the overfitting is one of the research challenges. Still it is a research challenge. By applying various fine tuning parameters, reducing the size or increasing the size, and increase the number of epochs, and so many dropout function if you are using. So then we can check the whether that overfitting model is erased or not by using these trial and error basis. With the help of various fine tuning parameters only we can check.
Madam,
Very
over to
good.
you, madam. KVN, madam.
Yes, sir. Sir, one more query. Please, can you give some data set names?
Yeah, very good, madam. If you want to download any data sets face recognition image data set, and iris data set, diabetic data set, traffic data set, and you can have COVID-19 virus CT scan image data set, X-ray images. If you want to download these data sets from Kaggle repository, GitHub repository, and UCA repository. So freely you can download. These are the different data types from different repositories. Very good question. Is there any other queries?
No, sir. Other queries, no. Madam, over to you. Madam.
Hello.
Yes, sir. Sir?
Hello.
Yeah, please.
Sir, good evening. Asadi Srinivasulu, sir.
Sir, good evening. Who's that?
I'm Murali, Dr. Murali.
One of the co-coordinator of this FDP, sir.
Oh,
my friend, my very close friend.
Yeah.
okay,
Madam,
okay,
over
sir.
to you,
How
madam.
are you, Murali,
Yes,
sir?
Fine, sir. Are you remembering?
Yeah. Sure, sir.
Yeah. Both together we started our research work initially, right?
Yes, sir.
Yeah.
Thank you.
Uh,
Yes.
okay, sir.
Madam, KVN election,
Sir.
madam. Over to
Yes,
you.
sir. Yes, sir. Sir, like with your permission, I would like to go ahead for the other procedures, sir.
Yes,
Shall I?
madam. No problem.
Please.
Yeah,
Yes,
sure.
sir. Yes. Good evening, sir. I am KVRN Lakshmi, Associate Professor from Narasimha Reddy Engineering College, and respected Asadi Srinivasulu, sir. It is a great indeed honor for me to extend a heartfelt vote of thanks on behalf of Narasimha Reddy Engineering College at the conclusion of the last session of the insightful online faculty training program on deep learning for social impact, atomic object detection in real-world applications, organized by School of Computer Science Engineering, Narasimha Reddy Engineering College, sponsored by AICTE et al. Sir, your insightful and engaging session on the topic Future Directions and Innovations in Deep Learning was highly appreciated. Your expertise and passion for the subject matter were evident throughout the presentation, and your willingness to share your knowledge with us was truly inspiring. We appreciate the time and effort you took to prepare and deliver the session for responding to the participants' questions and queries, sir. Your presence and participation have enriched our program, and we were grateful for your support. Once again, thank you, sir, for your contribution to the success of our online faculty development program. We look forward to future collaborations. Thank you, sir.
Thank you, ma'am.
Dilip, sir?
Madam, within.
Over to you, sir.
Okay, madam.
Sir, any photos are you taking? Let them.
I will share, sir. I will share to you, sir.
Okay, sir. No problems.